So, good morning, all. So, today we will discuss here Latin square design and a mathematical model and estimation of sum of squares and a test expected sum of squares. Concept of missing values Latin square design how to discuss here. So, explain the Latin square design, discuss the layout of LSD, explain the statistical analysis of LSD, and advantages and disadvantages of LSD. Here we know that there could be random block design here uses the experimental material in a heterogeneous. So means the extraordinary with respect to one factor is by experimental grouping. All the elements we are taking into a of homogeneous groups called we are in the blocks. The grouping carried one step forward here, one step forward. Among the units, we can take the Latin square design. So in the agricultural experiment, generally fertility gradient is not always known as such as a situation LSD in use and advantage. The LSD eliminates initial variability among the units and the two orthogonal directions. The Latin square design The Latin square design represents, in some sense, the simplest from a row column design. It is a row column design we are taking. We use it for comparing the M treatments and the M rows and N columns. Already told the treatments where rows and columns are represent the two blockings and rows and columns here. So therefore, Latin square are their com- combinatorial properties have been attributed by Euler. This is Euler 1782. So therefore, they were proposed uh, the experimental design by R.A. Fisher in 1925-1926. Although in 1788 already utilized the idea in 4 into 4 Latin square design for an agricultural experiment, the street 1987-88 we are taking here. So therefore, Latin square design LSDs. So we are taking here Latin square designs here. So before introducing the design, we define that we meant by Latin square. A Latin square is an arrangement of symbols in a square, such that each, each symbol occurs here early we have taken here once in which row and a column. One each row and each column we are taking here. When the fertility gradient into two different perpendicular to each other, so the design is used. So gradient means we have taken the main aim of the design reduce the fertility of the variation. So in the both directions. Suppose we have three rows and three columns. We have to first column ABC. Then we are changing the BCA, then CA. So we can change here the BAC, ABC, BC, and CA. We are changing. This is the route they were taking here. This is the design. This design is used in situation of rows. The rows and the columns are formed perpendicular to each other. The number being to equal to the number of treatments. The plans are arrangements here and has only to randomize the rows and columns. The rows and columns we are taking is NLSD. Only row columns you know, taking here. The treatments block and column effects are the assumptions we are taking here. The assumptions The assumptions we are taking here, these assumptions are, we are taking the conditions here. So these assumptions, treatments are block and column effects are additive. The errors are independently and normally distributed with mean zero and constant variance. Advantages and disadvantages of Latin square design we are taking here. So since the total variation is divided into three, namely rows, columns, and treatments, the error variance is reduced considerably. It happens due to fact that rows and columns being perpendicular to each other eliminates two heterogeneity up to the maximum extent we are, the maximum extent we are taking here. There is the square design. So is incomplete uh, three-way layout. Its advantage over the complete their way. So layout the instead of m cube with m cube units with only m square units. Why? Because the layout we are taking in place of m cube and m square. So therefore we need here 4 into 4 LSD. Latin square design Latin square design results in the saving square and 64 minus 16. That is the 4 square minus 16 here. So 4 into 4 64 minus 16 48. There is observations here over a complete three-way layout. The analysis creates no problem if any missing observation exists. So disadvantage of LSD. Anisha, I'm audible?
Yes, sir.
Okay. Disadvantage of LSD. The fundamental assumption. You listen to the advantage of LSD.
Sir, I have joined just now.
So again, I will tell you advantage of the LSD. Since total variation of divided into the three namely parts, rows and columns and the treatments. So it is a LSD means Latin square design. Square design means rows and columns and the treatments also we are taking here. In the error variance also neither considerably it happens due to the fact that rows and columns being perpendicular to each other. Why? Because rows and columns is separately perpendicular. Why means rows it is the same. Rows will be the opposites. Rows and columns is opposite side. Am I correct?
Yes, sir.
So therefore, eliminate the two-way heterogeneity up to a maximum extent. Two-way heterogeneity means we can take the values we have taken here in LSD. So therefore, LSD m cube in place of m cube units, we are taking m square units. So it 4 into 4 LSD. 4 into 4 how much? 4 into
16,
4,
sir.
4 times 64. M cube units how much? 4 into 4 into 4 how much?
64, sir.
So 64 minus m square is 4 into 4 16. So we can take the 64 minus 16 48 observations for completing three-way layout. So the analysis creates the problem, even a missing observation also we can take the existing. So we can take the missing also we can take here for the observations here also here. And also a disadvantage. What is the disadvantage? This is a 4 into 4 LSD. The fundamental assumption that there is no interaction between different factors may not be true in general. Why because it's true in not general. The assumption we are not no interaction. No interaction means there is it's true in general we are taking here. So therefore, the limitation of LSD is the equality of the number of rows and columns are and the treatments. We already told the layout of experimental material not square design, then LSD cannot be used. Why? Because it's not is equality the number of rows and columns and treatments. The main limitation of three is their main rows and columns and treatments. The layout of experimental is material is not square. Why? Because three we are taken, so it's not square. So the design of their LSDs cannot be used. Random block design RBD is accommodated if any shape of field where for LSD should be a perfect square. For smaller number of treatments, say less than 5, the degrees of freedom for error is very small, and thus the results are not reliable. Even though 2 into 2 LSD, I already told 4 into 4 LSD. Even in case of 2 into 2 LSD, degrees of freedom is error becomes zero. Such situations, the number of treatments should be increased the lattice square design. So we have to use 2 into 2, 3 into 3, 4 into 4. We have to take that by the depending on that. On the other side, the number of treatments increases in the size of Latin square increases and disturbances in heterogeneity. Analysis of LSD becomes a very much complicated if complete row or complete column is missing. Analysis of orbit is quite easy in such situations. So therefore, statistical analysis. Why IJK is equal to IJK is equal to 1 to M denote the response unit plot in the field experimentation. So we can take the plot in the field, plot in the field, plot in the field experiment, plot in the field experimentation we have taken here. So in the ith row and jth column is the respective the kth treatment. IJ is where and kth treatment we are taking. The triple IJK is the assumption of M2 of the uh, possible MQ values on LSD selected by the experiment. If S represents the M2 values, so see here the symbolical IJK belongs to S. So a single observation made per as per experimental unit. So therefore, mathematical model. This is mathematical model for Latin square design. The linear mathematical model I already told in the first unit. Yijk is equal to mu plus alpha I plus beta j plus t of k. Eijk, ijk means that it belongs to S we are taking here, where mu is the general mean effect. Alpha I, beta j and t r theta is the constant effects due to the ith row, that is jth column and kth treatment. Ith row, jth column and kth treatment respectively. Eijk is the error due to random component here. So therefore, assumed to normally distributed with mean 0 and variance sigma square Eijk follows here. That is IID. So therefore, that is IID we are taking here n0 sigma e square. Then estimation of sum of squares we are taking here. Estimation of sum of squares taking here. So therefore, the parameters of mu, alpha, I, beta, j, and ti are estimated. The principles of least squares are minimizing the sum error sum of square. Is called sum of ijk, eijk whole square, eijk, yijk minus alpha, I, beta, j, 2k square. So tk square means we are writing that the fundamental squares here. Partially differentiation, other partially means dou. Differentiate with respect to mu, alpha, beta, j, and tau k, and equating to 0 here. So therefore, mu bar is equal to y bar, alpha cap is equal to y bar minus y bar, beta j is equal to y j bar minus y bar. So it's equally subsequently is going to tau k is equal to y of k minus y bar. We are taking the continuous process here. Substituting the estimates, we write that G y bar is equal to grand total of the m square observation. R is equal to y bar total the m observations in I through, and y dot j. I dot means m observations in I through, dot j the total m observations in jth column. So see here all of you. Am audible?
Yes, sir.
Yes, sir.
మధ్య మధ్యలో మీరు ఆడిబుల్ అంటే చెప్పండి, వినపడుతుందో ఎట్లా తెలుస్తుంది. సో దేర్ ఫర్ TA, this is a very much most important. TK y bar is equal to k, the total number of m observations, the k treatment. Heuristically, we get sigma ijk belongs to s y ijk minus y bar whole square. So we are taking ijk, I am telling the row column and treatment here. Ijk belongs to s yij minus y bar plus y minus y dot plus y dot ky. These are row and column and treatment we are taking here. So yijk minus y bar minus y dot j minus y bar k plus 2yi. So therefore n m sigma y bar minus y bar whole square plus m sigma y bar j minus y bar whole square m sigma y bar k minus y bar whole square we are taking here. So this is a simplification of this one. So the total, the product of vanish of the is algebraic sums. The deviation that thus we can take the TSS is equal SSR plus SSC plus SST. SSR means what is SSR? What means R? What means R? Hello? Hello, I'm audible.
Yes, sir.
What is R? What is C? E means error. C means sum of squares of total. What is C? What is R?
Sir, rows and
Very
columns.
rows and columns. Who told?
Anisha.
Very good, very good, very good, Anisha. And so therefore, Anisha, rows and columns, very good. Rows and columns. So where? TSS. TSS is the total sum of squares. SSR and SST, SST and SSD are sums of squares due to rows and columns and treatments due to error, respectively. So therefore, TSS, you have to write summation of ijk belongs to it, that we write yijk minus r whole square. SSR, SR whole square, m sigma m yi bar minus y bar whole square. SST, SC square, m sigma m yi bar minus yj y whole square. SST, ST square, m summation of k y bar k minus y bar whole square. And SST, ST square, the C means column, row, R means row. You're taking SST total, ST square, m summation of k y bar k minus y bar whole square. That is the total error. TSS minus SSR minus SSC, SST. This is the total sum of squares in portion into the three sum of squares, where the degrees of freedom and the degrees of freedom in TSS here. See here the degrees of freedom I am writing, degrees of freedom you have to see here. Degrees of freedom we can take here. So source of variation, degrees of freedom, sum of squares, mean sum of squares, F ratio. Already I told in the earlier units also, the rows, the columns, treatments, errors. Am I correct? These are 4 units is there or not? Hello? Hello?
Sir.
Rows, columns, treatments, error. So rows is m minus 1, columns also m minus 1, treatments also m minus 1, error m minus 1, m minus 2, total m square minus 1. So a sum of squares, rows means SR square, SC square, treatment
Okay.
ST square, error SC square. So therefore mean sum of square is equal to, we have taken SR square is equal to SR square by m minus 1, column, that is a row. Then column square is equal to SC square by m minus 1. Then ST square is equal to treatment, that is ST square by m minus 1. Then error, all are squares, SR square, SC square, ST square. M minus 1, this is the m minus 1, m minus 2. Already yesterday's class we learned that ratio by the division of this MS1. FR, SR square by SC square. FC, SC by SC square. FT, ST by SC square. We have to take all SC square in the denominator, but in the numerator we have to take SR row, column and treatment. But error we have taken in the F ratio, the denominator part here. So for row effects, H naught alpha is equal alpha is equal to alpha 1 is equal to alpha 2 is equal to alpha m is equal to 0. Alpha m is equal to 0. For column effects, H naught B is equal B1 is equal to B2 is equal to Bm is equal to 0. So I am taking the two different elements, alpha and beta, for rows and columns here. So therefore, we can take the treatment effects H naught is equal T T T1 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 T2 is equal to Tm is equal to 0. So again, it's the alternative shell that alphas, betas, and thetas are not equal. Why? Because the rows and columns and treatments are different for at least one pair. For at least one pair, as explained earlier. I told that the test statistics FT, FC, FR. What is FT, FC, FR? Anyone tell me? What is FT, FC, FR? Treatment column row.
Treatments.
Treatment treatment column rows for F distribution with m minus 1 and m minus 1 and m minus 2. So the degrees of freedom under the above null hypothesis. F alpha is equal to F alpha is equal to F alpha m minus 1 m minus 1 m minus 1 and m minus 1 m minus 2 with the tabulated value of F distribution with m minus 1 and m minus 1 and m minus 2. Already I told m minus 1 and m minus 1 m minus 2 degrees of level of the FR greater than F alpha. Why? Because the rho and alpha is we reject the null hypothesis. I already told in the class also earlier. Less than means we can accept. Greater than means we can reject the null hypothesis. So therefore, otherwise, so the H naught alpha. Otherwise, we do not reject the null hypothesis. So similarly, we can test the H naught B also, H naught T also. We can check here. Then F test. Hence, F statistics under HO is given by, we can take that. F test in the LSD linear Latin square design, SR square by SC square, we can write that is equal to F of M minus 1 into M minus 1 into M minus 2 degrees of freedom. FC column SC square by SC square, that is equal to F of M minus 1, M minus 1, M minus 2. And F of T ST square by ST square, F of M minus 1, M minus 1, and M minus 2, same degrees of freedom. This is we are writing here. This one. Expectation of various sums of squares here. ESSR, M summation of alpha square, M minus 1 sigma E square. So this implies here this M minus 1. Left side, the right side I'm showing M minus 1, come to the left side, the denominator. We can writing in SSR by E into SSR by M minus 1. So the total M minus 1 we can treat here, we can write there M minus 1. M summation of alpha square, sigma square, we can write here. So EMSR, this is the SSR by M minus 1, we can write here. EMSR, we can write here. That is sigma E square by M minus 1 summation of alpha square. E of SSC columns, sum of squares of columns here. So therefore, M summation of Bj square M minus 1 sigma square E. Therefore, implies E SSC by M minus 1 come to the left. This is mean sum of column here. So therefore, sigma square M by M minus 1 summation of Bj square. E SST, that is a treatments here. So same again, the SST by M minus 1, we can read EMST. Sigma square E be M by M minus 1 not is equal to 1. This is M by M minus 1 summation of T square K. SSC M minus 1, M minus 2, sigma E square we can take here. So therefore, this implies here, SSC, M minus 1 member, this is called MSC is called sigma E square. What I am doing, I am writing the formula, the rows and column under treatment. I am taking the left side and applying the values. Are you understood, all of you? Hello? I am audible?
Yes, sir. Yes, sir.
Okay, this is most important. Please see here. Estimation of one missing value in LSD. Let us suppose that in M cross M Latin square design, the observation occurring in the ith row and jth column and kth treatment is missing. Let us assume the value xi. So R is the total number of observations of ith row. C means column. T means total observation in the kth treatment value containing to the x. So suppose we write here S total of the known observations. We can write here this is the main fundamental formulas here. The main fundamental formulas here. SSR is equal to R plus X whole SSR is equal to R plus X whole square by M plus constant with respect to X. So with respect to X means we have to derivate here S plus X whole square by M square.
Hello.
Just a minute. Just stay on the line for 1 minute, okay? Hello?
Okay, sir.
Okay, please. So therefore, E SSC by M minus 1 M minus 2 E M S S C sigma E square, estimation of one missing value in LSD. So let us suppose that in M cross M Latin square design, the observation occurring ith row and jth column here and receiving the yes, yes. Please stay on the line for 1 minute. There is no signal here. Okay.
Okay, sir.
Just 2 minutes. Stay on the line, all of you. Don't go away.
Okay, sir.
Please, please. Yes, E SSC by M minus 1 and M minus 2 is EMSC sigma E square. Estimation of, all of you ready?
Yes,
Yes,
sir.
sir.
Hello? Okay. Estimation of one estimation of one missing variable, one missing value in LSD we are taking here. Let us suppose that in M cross M Latin square design, the observation occurring ith row and jth column and kth treatment here. So already I told that SSR is called R plus x whole square by m, that is a constant with respect to x. S plus x whole square by m square. SS is equal to C plus x whole square by m. with constant with respect to this x plus x whole square by m square. SST is equal to t plus x whole square by m plus constant with respect to the x minus. So with respect to the x means what we are doing. With respect to the x means what we are doing here. So s plus x whole square by m. So we are with respect to the x we are partially derivating here. E is equal to residual sum of square SSC. TSS is TSS SSR SSC minus SST here. So x square minus 1 by m. R plus x whole square, c plus x whole square plus t plus x whole square we are writing here. So what is it with respect to the x condition we are taking here? R plus x and c plus x and t plus x. So therefore, there with partial derivation we are doing here. With partial derivation plus 2x plus x whole square by m square. So we'll choose x so as to minimize e. So we have taken the partial derivative dou e by dou x is equal to 0. 2x minus 2 by m. R plus c plus t plus 3x. That is a r plus x whole square. This is a constant. The partial differentiation constant is equal to 0. So we can write here r plus t plus 3x. What is 3x? Anyone tell me? What is 3x? Hello? Hello, I'm audible? వినబడుతుందా?
Yes, sir.
What is the 3x? What is the 3x? So we are partially differentiating. Monica is there? Okay. So dou e by dou x is equal to 0 is equal to 2x minus 2 by m. R plus t plus 3x by 4 s plus x m by m square. So there square m square minus 3m plus 2x is equal to, I am taking m r plus t plus t. We are taking the partial differentiation here. That is 2s. X bar is equal to m r plus c plus t. M r plus c plus t minus 2s, m minus 1 and m minus 2. The standard error, the difference of two treatment means SC is equal to under root of 2 m SSC by m. So means sum of squares here we are taking here. So this is the critical difference here, SC into T alpha by 2 at error degrees of freedom. Example, we are taking one example here. The example of petrol consumption by different makes of cars for illustrating randomized block design has been converted to one with 5 makes of cars to illustrate Latin square design. The effects on the driver on consumption rate have been eliminated in addition to the effect of speed by suitable modification of the experimental situation. For this purpose, 5 drivers were chosen and each driver was used on one of 5 days. On the day A, he drove 5 cars, each of different make, each car with a different speed. The arrangement of the drivers' speeds and makes was the following table. So drivers and is D1, D2, D3, D4, D5. There is the values 25, 35, 50, 60, 70. The values is given in the brackets. 19, 5, 16, 2, 26, A, B, C, D, A, B, C, D, E. So A, B, C, D, 5 values here. So therefore here it is equal to y is equal to 1, 2, 3, 4, 5. The difference ith driver driving the on ith day. So A, B, C, D, E is the 5 makes of the cars. Is the initial table that the car has been the make was driven by DA on the day with the speed of 25 miles per hour. So the alphabets in the other cells have similar meaning. The number of miles covered by gallon of petrol is shown in the each cell 19.5, 16.2. That is a shell we have right here. The design adopted by actually a Latin square design which makes a coarse treatment, and the drivers and the speeds are the two controlled factors representing the rows and columns. The observations of the miles per hour have been analyzed below and appropriate of the design here. So therefore, the correction of factor from the above table with the tables we have done here, 76.38. How it is came? Anyone tell me the correction of factor? Correction of factor. Hello? వినబడుతుందా? హలో హలో హలో
ఎస్ సార్ వినిపిస్తుంది సార్.
కరెక్షన్ ఆఫ్ ఫ్యాక్టర్ ఎట్లా వచ్చింది? 7638.76 ఎట్లా వచ్చింది? చెప్పాను కదా నిన్న మొన్న క్లాస్ లో 76.38.
గ్రాండ్ టోటల్
grand total m. So sum of squares of seed, that is the totals by 7719, that is total 7719 by 49, 7638 by 76 minus చేస్తున్నాం 80.73. Drivers also 7640, that is the total we are doing here. Is all the totals. This all the totals we are doing here. The total sum of squares also. Total sum of squares what we are doing? The total sum of squares. What we have to do, Monica? Bhavani. So total sum of square 7792.70, 76, 38.36, that's the values. So what is the output here? 153.9 for total sum of squares, 80.73 is the speeds, and minus 1.36. Tell me.
చెప్పండి సార్.
So వచ్చిన values నుంచి తీసేసాను 153.94, 80.73 minus 1.36 minus 65.42, that is 6.43. So therefore speeds drivers makes errors total. So total degrees of freedom ఎన్ని ఇచ్చాడు? 5 minus 1 4 కదా. టోటల్ ఎన్ని ఉన్నాయి చెప్పు? టోటల్ ఎన్ని ఉన్నాయి మొత్తం? టోటల్ ఎన్ని ఉన్నాయి?
టోటల్
టోటల్ ఎన్ని?
70 ఫస్ట్ దాంట్లో 25.
మొత్తం ఎన్ని ఉన్నాయి? టోటల్ ఎన్ని ఉన్నాయి?
70.
24 కదమ్మా, 25 కదా. టోటల్ 25. టోటల్ 25 లో ఎర్రర్ తీసేస్తామా? స్పీడ్స్ 4, డ్రైవర్స్ 4, మేక్స్ 4, 12 పోతాయి. 12 పోతే ఎర్రర్ ఒకటి పోతే ఎంత మిగులుతుంది? 12 కదా మిగిలేది. హలో
సార్ ఎక్కడ సార్ ఇది? ఫస్ట్ కాలమే కదా సార్ మీరు చెప్పే 25 డ్రైవర్స్ అండ్ డేస్.
అవును అవును. చెప్పండి.
పెట్టుకోండి మీరు, మీకు అనుకూలంగా ఎక్కడ ఉంటే అక్కడ పెట్టుకోండి. అక్కడ
భవాని చెప్పండి.
సార్
చెప్పండి.
25 ఉంది కదా సార్, ఆ కాలం లోనే కదా మీరు అనేది?
అవును అవును. స్పీడ్స్ ఎన్ని ఉన్నాయమ్మా?
స్పీడ్స్ 5 కదా సార్.
అంటే ఎంత? n-1 అంటే 4 కదమ్మా. ఇప్పుడు స్పీడ్స్, డ్రైవర్స్, మేక్స్ m-1, m-1, m-1 అంటే 4 కదమ్మా. అవునా? హలో 4 - 1 అంటే ఎంతమ్మా?
4 - 1 3.
5 - 1 కదమ్మా. 25, 35, 50, 60, 70 టోటల్ ఎన్ని?
5 ఉన్నాయి సార్.
5 - 1 అంటే ఎంతమ్మా? 4 వచ్చింది. అన్నిటికీ m-1, m-1 ఎర్రర్. m-1, m-2 అంటే 5 - 1, 5 - 2
ఓకే
ఎంత?
ఓకే అర్థమైంది సార్. 12 టోటల్ 12.
టోటల్ ఎంత? టోటల్ ఎంత? 12 plus 12 ఎంత?
24.
24. అర్థమైందా ఇప్పుడు?
Yes, sir.
ఎస్ఎస్ మీద వచ్చిన వాల్యూస్ రాసాం, అవునా? ఎంఎస్ ఎఫ్ ఫ్యాక్టోరియల్ ఎఫ్ టాబ్లెటెడ్ వాల్యూ రాసా, మీద వచ్చిన వాల్యూస్. ఇప్పుడు అర్థమైందా?
ఎస్ సార్.
ఆ టేబుల్ వేసా నేను, అంతకు మించి ఏం చేయలేదు నేను.
బనానాలు ఎంత తీసుకుంది?
నీళ్ళు కావాలమ్మా. So this is the value of interpretation. So the highly significant difference is the speeds with respect to the control petrol consumption. So there is highly significant difference between the makes with respect to petrol consumption. So this is the one. The second problem you have to see. Any doubts, ask me, I'll clarify. Open your speaker. So second problem you are seeing, all of you.
Sir.
Any doubts, ask me in this regard.
సార్
అడగండి.
7638.76 ఉంది కదా సార్ ఫస్ట్ సెమ్ లో కరెక్షన్ ఫ్యాక్టర్.
ఒక్క నిమిషం. ఫస్ట్ సమ్ లో ఏముంది?
కరెక్షన్ ఫ్యాక్టర్ 7638.76 ఉంది కదా.
టోటల్ చేయాలమ్మా, టోటల్ చేసి హోల్ స్క్వేర్ బై అయ్యాలి.
ఏం చేయాలి?
భవానీ,
సార్
కరెక్షన్ ఫ్యాక్టర్ అంటే జీ స్క్వేర్ బై ఎన్.
ఓకే.
జీ స్క్వేర్ బై ఎన్.
జీ స్క్వేర్ బై ఎన్.
సో 19.5, 21.7, 18.1, 14.8 ఇదంతా స్క్వేర్ చేసి బై వేయాలి.
ఓకే సార్, అర్థమైంది.
నేను చెప్పిన మౌనిక ఇస్ దేర్ ఇన్ ద క్లాస్ టుడే? ఓకే. ప్రియా, ఎనీ డౌట్స్?
Yes, sir.
ఆస్క్ మీ. Nothing. Okay. Any more? The second example, third example is also same. So you have to do this example. This is very much important for a compulsory. They will ask in the mathematical model Latin square design. Any more doubts? Ask me. I will clarify.
Sir, F-tabulated చెప్పండి సార్.
అమ్మా,
F-tabulated F ratio ఒకసారి చెప్పరా?
ఏది F ratio?
అనవా టేబుల్ లో F ratio ఒకసారి.
అనవా టేబుల్ లో F ratio చెప్పాలా నీకు? ఇగో వేరియన్స్ రేషియో ఇక్కడ చూడండి. ఎఫ్ రేషియో, ఎఫ్ఆర్ అంటే ఆర్ అంటే రో బై ఎర్రర్ స్క్వేర్. అర్థమైందా?
ఓకే సార్, ఫార్ములా ఉందా చూసుకోవాలి సార్.
ఇక్కడ పెట్టిన చూడు ఇప్పుడు.
Sir, assumptions and applications of LSD in the field experiment ante we have to write a problem, sir.
Yes.
We have to write problem on our own, sir. They won't be giving any question.
Where? Ask again the question.
The short answers, sir. Give the, MEQ.
Tell me.
Give the assumptions and applications of LSD in field experiment.
No. You write the advantages and disadvantages.
No, sir. That is not a
problem.
Applications only matter, no, sir. No need to write.
Only matter you have to write.
Okay. All the questions are related to theory only, no, sir. Problems will not come.
Only I told first problem that will become. That method will become.
Okay, sir.
Which one, sir? Example 1, sir?
148 is number 148.
Yes, that is the
148
assumption. Yes, that type of problems.
Okay, sir.
Any more doubts?
Nothing, sir.
All the best for main examinations.
Thank you, sir.
Thank
Today
you,
is
sir.
the class, sir.
What is your doubts? I already prepared. I will send in your WhatsApp by tomorrow morning.
Okay, sir. Thank you.
Any more doubts? Ask me. Hey, 6 members is there. Any doubts? Ask me. I will close it. Anisha, Monica, Shilpa, Priya, Tanvir.
Yes, sir.
So all of you, this 10th, 11th also I will give the important and I will close it. Okay?
Okay, sir.
Okay, sir.
Okay, sir.
Okay,
Right.
sir.
All the best.
Thank you,
Sir,
sir.
once
Thank
again,
you,
all
sir.
of chapters, any important question?
Yes. Just I
Like
told.
you
Just I
gave
told.
no, sir. 148. This method will come like that methods.
Yes, I will give you.
Okay, sir.
I already told. Bhavani, I already told. I will send you. All
Yes,
of you.
sir. Yes, sir.
Okay?
Yeah. Okay, sir.
All the
Okay,
best.
sir. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Any more doubts? Ask me. Shilpa, Monica.
Sir, you won't tell any 10th, 11th, you won't tell us, sir, now?
No need, Monica.
No need, sir.
Monica, no need.
Okay.
Monica,
Oh.
don't worry, no need.
Okay, sir.
Don't
Thank-
worry. Don't worry about that one.
Oh, okay, sir. Thank you, sir, then.
Right. Kundam.